Simplifying radicals. Being able to transform back and forth from radical to exponential form can help you greatly simplify radical expressions. Part A, the cube root of a to the sixth power, this could be rewritten in its exponential form as a to the sixth divided by 3. 6 divided by 3 is just 2, so the cube root of a to the sixth power could be rewritten as a squared. In part B, we have the cube root of w squared divided by the square root of w. We could rewrite the numerator as w to the 2/3 power, and the denominator could be rewritten as w to the 1/2 power. Our rules of exponents tell us we can subtract the exponents, so we have w to the 2/3 minus 1/2. We need a common denominator. Between the 2 and the 3, the common denominator is 6. So we have w to the 4 divided by 6 minus 3 divided by 6. Rules of fractions say you subtract the numerator once you have the same denominator. So 4 minus 3 is 1, which is where we end up with w to the 1/6 power. So at the beginning, the cube root of w squared divided by the square root of w is a big mess, but it could be simplified all the way down to w to the 1/6 power. The product property of radicals tells us that we can multiply everything underneath the same radical. If we have the nth root of a and the nth root of b that are both real numbers, as long as n is greater than or equal to 2 and is an integer, then the nth root of a times the nth root of b could be rewritten as the nth root of a times b. Remember, these properties have an equal sign, which means they can be read left to right or right to left. So let's multiply the cube root of 2 times the cube root of 4. They have the same index of 3, so they can be rewritten as the cube root of 2 times 4, which is the cube root of 8. The cube root of 8 is just 2, so that could be simplified. Whoops. The fifth root of 3x squared times the fifth root of 6x could be rewritten as the fifth root of 18x cubed. So you could rewrite them underneath the same radical. Simplify the square root of 50. Now 50 is not a perfect square. However, if you look at the factors of 50, so the factors of 50 would be 1 and 50, 2 and 25, etc. 25 is a perfect square. So we could rewrite 50 as 2 times 25 because 25 is a perfect square. So we can pull that apart, and this is what I meant by reading the property from right to left. We can pull that back apart to be the square root of 25 times the square root of 2. Square root of 25 is just 5. So the square root of 50 could be simplified to 5 times the square root of 2. Part B, the square root of 48x to the 15th, that could also be rewritten. While 48 is not a perfect square, the factors of 48 of 16 times 3, 16 is a perfect square. X to the 15th could be rewritten as x to the 14th times x. The square root of 16 is just 4, so this could be rewritten as 4 times the square root of 3. X to the 14th could be simplified. The square root of x to the 14th could be simplified to x to the 7th. So we can put this all together and end up with 4 times x to the 7th times the square root of 3x. The quotient property says that if the nth root of a and the nth root of b are real numbers, as long as b does not equal 0, and n is greater than or equal to 2, and is also an integer, then the nth root of a divided by the nth root of b could be combined underneath the same radical as the nth root of a divided by b. So we could simplify the square root of 75 over 81. This would be a case of reading it from right to left, because we could rewrite that as the square root of 75 over the square root of 81. While the square root of 75 is not a perfect square, it does have factors of 25 times 3. And the square root of 25 is just 5. 5 times the square root of 3 divided by, and the square root of 81 is just 9. Now simplifying the square root of 64 times x to the 5th divided by 2 times x cubed, we could pull it apart because 64 is the same thing as 32 times 2. So we can divide out the 2, then x to the 5th and x cubed. Rules of exponents say you subtract the exponents, so 5 minus 3 gives you a 2. (32) is not a perfect square, but it does have factors of 2 times 16 hiding inside of it. Square root of 16 is just 4. X squared, the square root of x squared is just x. And we can't simplify the square root of 2 anymore.